Hi guys, today we're going to be solving some of the questions we are given as a take home in our previous lesson on instantaneous and average acceleration, velocity and speed. In our previous lesson, we did quite a very good job on this. We are given some questions to test ourselves with to see how much we got from this very lesson. So we're given two questions, and this very question was the first question with S sub questions. So an object moves along the x-axis in a straight line according to the equation s equals to 3.00 t squared minus 2.00 t plus 3.00, where x is in meters and t, which is the time, is in seconds. Now we are asked to solve for all this. Now, how do we solve this? How do we go about this? Now, it's very simple to approach this. If you've not seen the previous lesson on this, I'll love you to go ahead and see that very lesson because it will help you not to be left behind. So don't forget, here we are talking about the first question. We have to get average speed and average velocity. Now it looks crazy for us to be asked to get average speed and average velocity. So how do we solve for the two of them? Now don't forget, the body moves in a straight line. The body moved from A to B, for example. The body was not said to move like this, and like this. So the body just moves in a straight line. So we can say for sure that this is displacement from here to here. And also we can also say that this is distance covered from here to here. So it means we can get average velocity, which is displacement over time taken, and average speed also, which is distance over time taken. So now the first thing we are going to do is we are going to get the value. We're going to get, we're going to write, let's write out our equation first. That's the first thing we have to do. Let's quickly write out our equation. So here we have displacement equals to 3.00 t raised by 2 minus 2.00 t, then plus 3.00. So this displacement here, this is time. So it means it's very easy for us to get, our velocity. We're talking about velocity here because we have displacement and time. So the first thing we have to do, let's write out the formula for average velocity. So average velocity is equals to what? You all know if you've not seen that previous lesson, you see that average velocity is change in displacement over change in time taken. So what changes displacement? Displacement 2 minus displacement 1 over time 2 minus time 1. So what we just have to do first is to get our our displacement. So we've been given the equation already. So what's the first time? The first time there is 2 seconds, while the second time is 3 seconds as I'm given. So time 2 seconds, time 3 seconds. So for time 1 is 2.00 seconds. So if time 1 is 2.00 seconds, what's going to be displacement 1? Displacement 1, we just have to fix in this value. So fixing our t, anywhere we see our t, we're going to put our 2 seconds. So if displacement, if time 1 is 2 seconds, so displacement 1 will be 3.00, then the time is 2 seconds, 2.00 seconds, raised power 2, then minus 2.00, time is 2.00 seconds, then plus 3.00. So what's going to be the displacement? The displacement will be this 3.00, 2 raised power 3 is 4, minus 2 times 2 plus 3. So displacement 1 is 12 minus 4 plus 3. So displacement 1 will be 12 minus 4 is 8. 8 plus 3 is 11. Displacement 1 is 11 meters. So that's the first displacement. So quickly, let's get our second displacement. So if time 2 is 3 seconds, that's what time 2 is. So displacement 2 will give us 3, open our bracket, 3 for 2, plus 2, open our bracket, 3, then plus 3, just like this. So displacement 2 is equal to 3 for 2 is 9, 9 times 3 is 27, minus 2 times 3 is 6, plus 3, 27 minus 6 will give us 21, 21 plus 3 will give us 24 meter. So right here we have our displacement 1 to be 11 meter, displacement 2 to be 24 meter. So it's high time we get what I have to get in the first question. So let's see quickly. Let's get the values they want us to get. Since we've got now displacement, we've got now displacement. So don't forget displacement 1 is 11 meter time 1 is 2 seconds. Displacement 2 is 24 meter and time 2 is 3 seconds. So we have everything. We need all the parameters already gotten. So the next thing we just have to do is to put them into the formula. We have a formula ready. So don't forget average. The first question is average velocity and average speed. So average velocity is change in displacement over change in time taken. So displacement 2 minus displacement 1 over time 2 minus time 1. So the side time we solve for this. The average velocity is displacement 2 is 24 meter minus displacement 1 11 meter. Time 2 is 3 seconds minus time 1 2 seconds. What do we have? 24 minus 11 is 13 meter over 1 second. So average velocity is 13 meter per second. As easy as that. That's just that for average velocity. So now how do we get average speed? And don't forget this velocity. Velocity is a vector quantity, so you can have an arrow like this on it. And also this is a vector quantity. Displacement is a vector quantity also. So how do we solve for average speed? Now we've gotten our average velocity as 13 meters per second. So how do we solve for average speed? That's the next thing we have to look at now. How do we solve for average speed? Now don't forget, average speed is different from average velocity. Velocity and speed are not the same. They're entirely different. So how do you solve for average speed? Average speed, the formula is total distance traveled over total time taken. Total distance traveled over total time taken. It's very, very important for you to note this. So when you say total distance, you have like distance 1 plus distance 2 plus distance 3 and so on and so forth. It depends over time 1 plus time 2 plus time 3. It's very different from average velocity. There's a clear difference. This is a scalar quantity. This is a vector quantity. So it's going to be total distance by total time taken. So what are the two distances we've been given? We're given distance 1 to the 11 meter, distance 2 to the 24 meter, and time 1, time 2 to the 2 and 3 seconds respectively. So distance 1 is 24 meter plus distance 2 is 11 meter over plus time 1. Time 1 is 2 seconds plus time 2, which is 3 seconds. So 24 plus 11 will give us 35 meter. Then 2 seconds plus 3 seconds will give us 5 seconds. So we divide 5 here 1, 5 here 7. So the average speed is 7 meter per second. As simple as that. Okay, it's time for us to solve the next question, the next sub question under the very first question. So the next you're asked to solve for the instantaneous speed or velocity at time 2 seconds and time 3 seconds. Now, how do we solve for instantaneous speed or instantaneous velocity? Now, the part is this. We said in our previous lesson that instantaneous speed is the same thing as instantaneous velocity. Let's talk about instantaneous speed. We're talking about instantaneous speed is the same thing as the modulus or the size of instantaneous velocity. We said this already in our previous lesson. So whenever we are asked to get instantaneous speed, it's the same thing as getting instantaneous velocity. Once you get instantaneous velocity, that's your instantaneous speed. So now, before we could get instantaneous speed, as you can see right there, we have to look for a way to differentiate. So if you don't understand differential calculus, I took just a bit of it in the previous lesson. You will not be able to get what we're about to take right now. So we have to differentiate. First of all, let's write out our equation of motion. X is 3.00t minus 2.t squared, I beg your pardon, minus 2.00t, and plus 3.00. So the next thing we have to do right now is to differentiate this. So out of differentiate, change in displacement of a change in time taken, dx the t, will give us velocity along the x-axis at this time interval, this instantaneous velocity, or rather instantaneous speed. So quickly let's differentiate. What do we have? This we multiply all this, then we take 1 away from it. This 3 raised by 1, this t raised by 0. So this is 2 times 3.00 t raised by 2 minus 1. Right here, minus 1 times 2.00 t raised by 1 minus 1. Then plus 0 times 3.00 3 raised to 0 minus 1. Now this is a direct method. It's very simple. Anyone could understand this within seconds. So just take the power, use to multiply what you have right there, use the power to multiply the coefficient, then take 1 away from the power. As simple as that. So you just do that all through and you're done already. You differentiated. So what do we have? This dx over the t equals to 2 times this is 6t. That's what we have. 3 raised by 2 minus 1 equals 1. Minus 3 raised by 1 minus 1 minus 1 is 0. So 1 minus 1 is 0. 3 raised by 0 is 1. So 1 times this is 2. So 0 times all this. This is what we have. So right here, we have our velocity or displacement already at this tiny instance. So what I want us to get, I want us to get instantaneous speed or velocity at time 2 seconds and time 3 seconds. So it's very simple. So what's our instantaneous speed at time 2? Instantaneous speed at time 2, just fixing the value. 6 times 2 minus 2. 6 times 2 is 12. 12 minus 2 is 10. So just 10 meter per second. Just 10 meter per second. As simple as that. That's that for instantaneous speed or velocity at that time. So the next instantaneous speed at time 3 seconds will give us 6 times 3 minus 2. 6 times 3 is 18. 18 minus 2 will give us 16 meter per second. So these are the instantaneous speed or velocity at these two time interval, 2 seconds and 3 seconds. As simple as that. Okay, the third question. So that's very question one, the third sub question. Now we are asked to get the average acceleration between time 2 seconds and time 3 seconds. And don't forget, just like the very first question, average speed or average velocity. So this time around, we have to get average acceleration. Now the question is, what is the formula for average acceleration? That's the question. Now think about acceleration here, which is a vector quantity. Average acceleration is change in velocity over change in time taken, so which is velocity 1, the final velocity we call that, minus velocity 2, and velocity 2 minus velocity 1, I mean, a final minus initial over time 2 minus time 1. But what do we have? What we have right here is just the equation given to us as displacement equals to 3.00 t squared minus 2.00 t plus 3.00. So now it's going to use this equation of motion 3.00 t squared minus 2.00 t plus 3.00. Now don't forget in last question 2 we differentiated to get the velocity. We're going to be doing double differentiation. So you differentiate first and after that you differentiate according to the second principle. So first of all, change in displacement by change in time taken. After all we did, we got 6t minus 2. That's what we got. So now after getting this was velocity at this time interval. So velocity at this time is 6t minus 2. So how do we get acceleration this time around? Now, for us to get acceleration, we don't even need to differentiate because we are not asked to get instantaneous acceleration. We are asked to get average acceleration. There's a difference between getting instantaneous and getting average. You understand? So if you're asked to get instantaneous acceleration, we asked to, we require to differentiate. But this time we have to get average acceleration. We just need these values. We only need the velocity the way it is, which is v equal to 16 minus 2. So at what time interval? We are given two time intervals. First time 1, 2.00 seconds. Time 2, 3.00 seconds. So what we just have to do, since it's average acceleration, we just have to fix in the value. That's what we have to do. So at time 1, 2 seconds, so velocity 1 will be 6 times 2 minus 2. 6 times 2 is 12. 12 minus 2 give us 10 meter per second. That's what we have. And next at velocity 2 now is going to be what? At time 2, the 6 times 3 minus 2. 6 times 3 is 18. 18 minus 2 gives us 16 meter per second. So we've gotten our velocities, and so it's I time we get our average acceleration. So how do we get our average acceleration? Look at that formula up there. Average acceleration is change in velocity minus change in time taken. So velocity 2 minus velocity 1, what's velocity 2? 16 meter per second minus velocity 1, 10 meter per second over time 2, 3 seconds minus time 1, 2 seconds. So what do we have? 15 minus 10 is 6 meter per second. Time 2 minus time 1 is 1 second. So what do we have? 6 meter per second squared. That is that for average acceleration. Don't forget there's a clear difference between average acceleration and instantaneous acceleration. If it's instantaneous, we'll be asked to differentiate this thought again for us to get our acceleration. And for the fact that it is average acceleration, you don't need to differentiate. Get the time given to you, fix them in, get all you have to get, then use the formula. As simple as that. Okay, guys, we have two more questions to go. We have D and E for the very first question, two more questions. So here we have to get instantaneous acceleration at time 2 seconds and time 3 seconds. Let's quickly see our equation of motion. X is 3.003 squared and minus 2t minus 3.00t plus 3.00. Now don't forget the velocity we got here at the time interval. We got 6t minus 2. That is the velocity that we have. So how do we get instantaneous acceleration at time 2 seconds and time at time 3 seconds? At those two time intervals, how do we get our instantaneous acceleration? Now to get instantaneous acceleration is very, very simple. But we, first of all, have to look for a way to differentiate this. We have velocity equals to this. So we have velocity and we have time. So it's very easy for us to use our differential calculus. So change in velocity over change in time taken. Don't forget, acceleration is velocity over time taken. So change velocity over change in time taken is simply acceleration along the x-axis. And so that's what we're going to get. We're going to get acceleration. So quickly, let's differentiate this. So if v equal to this, change velocity by change time taken will be this t raised to 1, 1 times 6 raised to 1 times 6 t raised to 1 minus 1, that's t raised by 0. So minus 0 times 2 t raised by 0 minus 1. This is gone already. So what do we have? This is this 6 t raised by 0, which is ordinary 6. So what is going to be our instantaneous acceleration at this two time interval? So don't forget the C series puzzle, which is just ordinary 6. So our instantaneous acceleration at this two time interval at time 1, which is 2 seconds, if you fix it in, so the first instantaneous acceleration would be 6 to raised by 0, which is 6 times 1, 6 meter per second squared. And if you fix the other one in the second time, 3 seconds, it's going to be 6 times 3 raised by 0, which is 6 meter per second squared. So instantaneous acceleration for both time is 6 meter per second squared. As easy as that. So quickly, let's look at the last question. The last question there is, at what time is the object at rest? That's a very pretty question. At what time is this body at rest? Now, if a body at rest, if a body is at rest, I mean, it means the velocity of that given body is, the velocity of that given body is 0 meter per second. That's what it means. So it's very simple. At what time is the body at rest? At what time is the velocity of that body 0? So that's what we're going to look for. Now, thank God we have this ready. So dt equals to 6t minus 2. So if the body is at rest at 0 meter per second, you know what that means? At what time is it? At 6t minus 2. So it's just very simple for us to collect our likes and send this over here. So minus 2 crosses to this place becomes 2 equals to 60. So divide both sides by 6. So we have our time is 2 over 6. 2 year 1, 2 year 3. So you divide 3 in 1, it gives us 0 0.333 in a sort of a recurring decimals seconds. So the body is going to be at rest at 0.3 seconds or 1 over 3 seconds. As easy as that. Okay guys, here was a very final question we're given. This was question 2 we're given in our previous lesson to test ourselves with. Now we are asked to solve for all this. Now look at the question. A body travels with an acceleration of this. Now we're given the equation of the acceleration. That's an instantaneous acceleration, as you can see. Acceleration at a given time interval of minus 12t squared plus 4t plus 3 at a given time instant. Now, how do you know instantaneous acceleration of velocity? As you can see, if it's instantaneous acceleration, there'll be a time attached to it. You will surely be told, probably even though you're not told, you can see it for yourself. So the body travel at this given time interval, so then we ask to solve for the velocity of the body at time 4 seconds. And also we have to solve for the average acceleration of the body between time 3 seconds and time 5 seconds. Now it's very simple. The first thing you have to do is to write out the equation we are given. We're given acceleration at this time interval to be minus, or the other, minus 12t squared, then plus 4t, plus 4t, then plus 3. Now, the first thing we have to do here, since we have to get the velocity of the body at time 4 seconds. Now, we've been given the acceleration of the body, so we are asked to get a velocity. How do we get velocity from this very given instantaneous acceleration? You're just going to have a reverse reaction. Don't forget the previous questions we solved. We were given we were given a couple of things like acceleration, displacement, like velocity and displacement mean, and what did we do? We differentiated to get what we want. But now we are given acceleration at this given time interval, and we're asked to get the velocity. So all we just have to do is to integrate. Integration is the opposite of differentiation. So when you differentiate a thing, you integrate it to bring it back to what it was. So now we're going to integrate. Don't forget, integration is the stark opposite of everything we do under differentiation. So what do we have to do? So for us to differentiate this, we're going to differentiate the acceleration, and also you're going to integrate, I beg your pardon, integrate this also uniformly. You're going to integrate them like this. So when we integrate this two, what we're going to get, you're going to get our velocity at this time interval. You're going to get our velocity actually. You're going to get our velocity. So what do we do? How do we integrate? Integration is different. For differentiation, you use this to times this and minus. But for integration, you're going to do the opposite. So first of all, we write this out, minus 3t squared. We add 1 to this. So after you've added 1 to the power, unlike the differentiation that you have to subtract, after you have added 1 to the power, the next thing you do is 2 plus 1 is 3. Use the 3 to divide this, then plus this t raised power 1. So there's 4t raised power 1, add 1 to the power. 1 plus 1 is 2, so use the 2 to divide what we have here. Well, this is plus 3t raised power 0. Add 1 to the power. 0 plus 1 is 1. Use 1 to divide what we have here. So we're almost there, as simple as ABC. So what do we have? Our velocity at this very point is 3a1, 3a4 minus 4 t raised power 3, then plus 3a1, 3a2, 2 t raised power 2, then 1 times this is 3, 3 t raised power 0 plus 1 is 1. So this was what was given to us before it was differentiated to this. Originally it was velocity equals to minus 4t cubed plus 2t squared plus 3t. That was then differentiated. Now just imagine if you have to have a reverse 3 times 4, 12, minus 1, that is minus 12t squared. 2 times 2, 4, minus 1 plus 4t. And 1 times 3 is 3 minus 1, just minus 3. So now we have our velocity, so it's time for us to solve. Now we are asked to get the velocity of the body at time 4 seconds. So velocity of the body at this very given time, 4 seconds, will be minus 4, 4 raised power 3, plus 2, 4 raised power 2, plus 3 times 4. So minus 4, 4 raised power 3 is 4 times 4 times 4, which is 64. Then plus 2, 4 raised power 2 is 4 times 4, which is 16. 3 times 4 is 12. So minus 4 times 64. Now what will that give to us? 4 times 4 is 16, minus 2, 56, plus 32, plus 12. So minus 256 plus 32, what are we going to get there? What do we have? We have minus 2, 2, 4, that is it, 4, 2, then plus 12. Minus 224 plus 12, what are we going to get there? We get minus 212 meter per second. It means, this is what we have, this is our velocity. So it simply means the body was moving at a speed in the negative axis. As simple as that. So that's that for velocity of the body at time 4 seconds. Okay, let's look at the second sub-question for question 2. Now we're asked to solve for the average acceleration of the body between time 3 seconds and time 5 seconds. Now how do we solve this? It's very, very simple for us to solve this. It's very simple for us to get our average acceleration. Now don't forget we have our velocities already, to be minus 4t cubed plus 2t squared plus 3t. So now how do we solve for average acceleration? Now don't forget time 1 is 3 seconds, then time 2 is 5 seconds. Now it's very important, as I said, for you to note the conspicuous difference between average acceleration and instantaneous acceleration. So it's very important. If we are asked to get instantaneous acceleration, don't forget this is the instantaneous acceleration. All just have to do is just fixing our figures. But we are not asked to get instantaneous acceleration. We are asked to get average acceleration. So for you to get average acceleration, don't forget the formula for average acceleration. Average acceleration, as been said, is change in velocity over change in time taken. So that's just the major formula. That's the formula for average acceleration. So you will need velocities to get average acceleration. But for you to get instantaneous acceleration, you don't need velocities at all. You just need your acceleration, and then you're good to go. That means you may have to differentiate the velocity. So quickly, let's get our velocities at different time intervals. So for time 1, velocity 1, just fixing your value, minus 4 times 3 raised by 3 plus 2, 3 raised by 2 plus 3 times 3. 3 raised by 3 is 27. 27 times 4, 4 times 7, 28, 4 times 3 is 10, minus 108. Then plus 3 raised by 2 is 9, 9 times 2 is 18. 3 times 3 is 9. So what do we have? 18 plus 9 is 27. So minus 108 plus 27 will give us minus 81. That's meter per second. That's the first velocity, velocity 1 for this very given body. Minus 108 plus 18 is, let's check that out again. Let's make sure we're right. That's minus 90. Minus 90 plus 9 is minus 81 meter per second. So for velocity 2, what do we have for velocity 2? As simple as that, so just fixing the time. Minus 4 right here, minus 4. 5 raised by 3 by times 2 plus 2. 5 raised by 2 plus 3 times 5. So velocity 2 will give us 5 raised by 3 is 5 times 5, 25, 25 times 5 is 125. So 125 times 4, 4 times 5 is 20, 4 times 2 is 10 plus 1, so that's minus 500. 10 plus 5 is 5, 25, 25 times 2 is 50 plus 15. As simple as that. So minus 500 plus 50 will give us minus 450. Minus 450 plus 15 will give us minus 435. Minus 435. So I hope we are right. Minus 500 plus this is minus 450 plus this. This is 65. Minus 435 is correct. Meter per second. So right away we have our two velocities. So there's velocity 1 and there's velocity 2 at time 1 and time 2. So how do we solve for the average acceleration? Average acceleration is very easy for us to solve for since we have all our parameters already. So that's going to be velocity 2 minus velocity 1 over time 2 minus time 1. So what's velocity 2? Velocity 2 is minus 435 minus velocity 1 is minus 81. You need your mathematics skill to be quite able to average for you to understand what we're taking. So what's time 2? Time 2 is 5 seconds minus time 1, 5 seconds minus 3 seconds. So what do we have? Minus 435 minus 81. That will give us, just solve it down here. Minus 435 minus 81 will give us minus 435 plus 81 over 5 seconds minus 2 seconds is minus 2 seconds is 2 seconds. So what do we have? Minus 435 plus 81. What would that give to us? That will give us minus 374 over 2. Minus 374 over 2. The 5 minus 1 is 4 for 3 minus 43 minus 7 is 35. I mean, I beg your pardon. Minus 354 over 2. That's what we have. So you're going to divide 2 here 1, 2 here, 2 in 3 is 1 remainder 1, 2 in 15 is 7, 14, remainder 1, 2 in 15, 17, 2 in 14 is 7 again. So minus 177 meter per second. That's what we have. That's 177 meter per second is the average, meter per second squared, I beg your pardon, is the average acceleration. As simple as ABC. So that's just that for everything. So these are the solutions for all the take-homes we are given. So if you got them all right, it means you're very good. You understand what instantaneous acceleration, average acceleration, velocity, and speed, what the simply are. So that is that for today. So we've come to the end of today's class. So if you found this very lesson resourceful, plus I would love you to to subscribe to the very channel. You can follow me on Facebook also at Revelation of. You can also subscribe to the very channel, my YouTube channel at Edu Mosaic. So please also share this lesson if you found this lesson resourceful. So at this very point in time, we're going to continue to this lesson. See you in the next lesson. Thanks.